All right, advent of code day 8, AOC 8. Let's give it a few seconds. Okay. Go ahead and get the input open. Okay. Let's see what we got today. I'm going to guess something with a 2D array. Seems to repeat the patterns each year. On day 7, he had the searching last year or 2 years ago. Halting. All right, int code. Okay. Okay. INA. Is it in this order? So wait. Increase or decrease single variable called accumulator. Increase the accumulator by 7. Let's print a. What? Oh, is this still building with Lua? No. Tools. Dang it, it's broken. No. Build system Python. A equals a. I dot split for I and a. Oh, just that. Okay. No, for I and a. Wait, now it is range length of a at I at 1 equals int of itself. Yep, okay. Is it in this order? No operation does nothing. Jumps to the next instruction relative to itself. The next instruction to execute is found using the argument with an offset. Skip the next instruction. Continue to the instruction immediately below it. Okay. So pause equals 0. So what's the stopping condition? There's nothing. Accumulator. Let's see. 0. Okay, so while pause is less than it's accumulator to 5 and jump -3. Only before the program would run instruction a second time. Okay, so scene equals set. It's not in scene. Let's see if add pause at 0 is, we only have to check for ACK, then plus equals a at pause at 1. Elif at pause is, no, it's just JMP. Then pause plus equals a and pause at 1. It's gonna bite me later. Else pause plus equals 1 to the accumulator. From 1 to 2. We know it just goes pause plus equals 1. Do I try it on the sample? Just run it. No, run this, idiot. Oh, right. Scene.add pause. Okay, so we just have to print ACK. Was it 5? No. Wait, yeah, it is. Run it again. Oof. Somewhere in the program, either it's supposed to be an up or it's supposed to terminate accepting execute instruction immediately after the last instruction in the file. We change the first instruction from not plus 0, it would create a single. Change the second and last instruction. Okay. So how can we do that? Change pause is 0. Let's see. If a at change pause at 0 is JMP equals, what was it? It's NOP. Elif NOP, then make it JMP. Wait, how can we do this? if pause equals length of a minus 1 break, then you can do else. Continue, I guess. So while true, wait, no, we would want to do change pause. This equals 1. Oh, wait. I think we might want this here, yeah. And say a break there. Wait, hold on. Pause. Oh yeah, then that's when you want to stop equals should stop, then should stop equals true. Break. Then this is what we want to do, change pause plus equals 1. So let's try this. What? What happened? Somehow change pause went out of range. Change pause. Okay, so we have to reset scene here. Let's see, scene equals set. Okay, so we have to reset pause to 0 as well. What now? Pause, set, what's going on? Oh, right, we have to change it back. So let's see. Why'd you gotta mess up like that? Do that. Something went wrong here. You should stop. Wait, should stop. So we're flipping it, and then pause not in scene. Wait, no, I think this should be equals the length of pause, right? What's going on? Alright, we have to reset ACK, that's why. Yeah, this seems to work. We can try it on the real thing. Nice. All right, 830, not bad. That was not too bad. All right. So what's going on here? Let's refresh that. So basically, looks like this is the start of some int code stuff. So your flight, I didn't actually read this before. Flight to the major airline hub reaches cruising altitude without incident. While you consider checking the in-flight menu for one of those drinks that come with a little umbrella, you are interrupted by the kid sitting next to you. Their handheld game console won't turn on. They ask if you can take a look. Oh, so good. We're not going to come back to this unless the same kid bothers us later in the future. You narrow the problem down to a strange infinite loop. The boot code. All right. You should be able to fix it, but first you need to be able to run the code in isolation. So basically, you have the ACK, which is like a counter. Jump is the move instruction, basically. And NOP means ignore it, which it's only ever used in part 2, I guess. So yeah, in part 1, you just have to figure out what values in the accumulator after the code runs. So it knows that it infinite loops, so once you see a state that you've been in before, then you just stop the program. And then in part 2, so you figured out the problem, so that one of the instructions got corrupted, and you know it's either the NOP or jump command. So you just have to go through trying all of them and flipping them to the opposite one, and then the program is supposed to terminate normally. And so once you find the one to flip, then you just have to say what the value of the accumulator was. Yeah, that one was not too bad. I guess I ended up not really using this. Let's see, so basically, oh, I guess I kind of messed up my code, didn't I? Or no, yeah, I guess I did. I can fix it later. But yeah, so in part 1, here I'm gonna copy this. Let me go ahead and so that's my command to push to GitHub. Messy solution. Okay, so let me try to fix to what I had before. So that solves part 2. I don't like how it does that when you paste. I can fix this later, but I can just show what I have for part 2, I guess. So in part 2, we flip it so that we're changing one of the instructions at a time. It's like if it was a jump, then flip it to NOP, and if it was NOP, then flip to jump instead. Then we check going through the program to see first we're saying that we have not seen this state before, and then we add the current one, and then we try to go through the program as that, and then at the bottom, if you ended up in an infinite loop, then it's like, well, let's try flipping the next instruction. So let's flip the current one that we already had back, and then we try changing the next instruction instead. Yeah, so that is the program. Thanks for watching.